These are notes on ultraviolet light. Ultraviolet light is part of the electromagnetic spectrum. You may have heard about that in 8th grade. This is a visual of the electromagnetic spectrum. It's all different wavelengths of what's called electromagnetic radiation, although people often refer to it as different wavelengths of light. So you can see where there's a rainbow here, that's visible light, and then ultraviolet light, what we're going to be talking about, is right there. And on the long wavelength, this side is the long wavelength part here, and this side is the short wavelength. Longer wavelengths have less energy than shorter wavelengths, so you've got things like your radio waves are right there. On the extreme high energy side, you've got your gamma waves right there. And today we're going to be talking about electromagnetic light, or I'm sorry, ultraviolet light. And we're going to get into this more later this year, but it won't be sunny enough to do this lab. So this is a nice lab to start the year with because we can go outside, and it's a good lab that you can plan yourself. There are different types of ultraviolet radiation depending on whether it's closer to the visible spectrum or the X-ray spectrum. So the first type is called UVA light. And UVA light is lower intensity, least energetic ultraviolet light. So it's closest to the visible spectrum. And you've probably heard this term UVA, you've probably heard UVB on the back of sunblock. So sunblock will often say protects against UVA and UVB light, or sometimes it says it's broad spectrum, meaning it's both UVA and UVB light. So UVA, as I said, is the lower intensity light. It's 95% of the ultraviolet light in our atmosphere. It's responsible for tanning your skin, wrinkling your skin, aging it, and what's called leathering. If you know somebody who has worked outside a lot, maybe in construction or in farming, their skin almost takes on this leathered look, almost like an old, worn look, and that's because of the ultraviolet A light in the atmosphere that's aging their skin. And it can start some skin cancers. It used to be thought that ultraviolet A didn't start any skin cancers, but we now know that some of the less harmful skin cancers are caused by ultraviolet A light. There's also UVB light, which is ultraviolet B, and that's higher intensity, more energetic ultraviolet light, so further from the visible spectrum, closer to the X-ray. And it is 5% of the ultraviolet light in our atmosphere. So it's higher intensity, more energetic, it's more damaging, but it's also only 5% of the ultraviolet light in our atmosphere. And that's responsible for burning, reddening, and the more harmful skin cancers. If you've heard of or know somebody who's had melanoma, that's an extremely deadly form of skin cancer, and that's caused by exposure to ultraviolet B light. And then there's also actually ultraviolet C light, which is the highest intensity, most energetic ultraviolet light, but our atmosphere filters out ultraviolet C, so that never reaches down to Earth. So think about, we have probes in class that test for both ultraviolet A and ultraviolet B, UVA and UVB light, and start thinking about what kinds of things do you want to test? What do you want to know about? Do you want to know about UVA light or UVB light or both? Do you want to test, for example, how different brands of sunglasses filter the ultraviolet light, or how different SPF sunblock filters the ultraviolet light? Think about what you'd want to test, and then Friday in class we'll talk a little bit more specifically about the lab and what that's going to look like. Please make sure if you have any questions, you put them in the comments section on YouTube. It won't show up right away. I have to approve it, but I will make sure to get on there and get those questions updated so people can see what other people have asked. And certainly if you have an answer to any of those questions, feel free to put in a comment there and you can answer them.